Today's lesson is not a new one. It is more of a review of stoichiometry and limiting reactant that now incorporates solutions and the mole calculation that we can use for solutions. Now that we're aware of molar concentration and its mathematical formula, we can apply that into stoichiometry when we're dealing with chemical reactions that deal with aqueous solutions. So we now have three mole formulas that can potentially be used in any kind of stoichiometry calculation. There was the initial mole formula way back when of moles equaling atoms or molecules over Avogadro's number. It was the first one we were introduced to, but admittedly, it's really not very commonly used because we can't really measure atoms or molecules. So it's kind of nice to know, but it's not practical in any way. The second mathematical formula is the most commonly used, which is mass divided by the molar mass of a substance. This is good if you are dealing with the mass of a solid, or you're trying to figure out the mass of a gas that has been released. This is a very practical formula and commonly used. The third mole formula is the one associated with molar concentration in solutions. And this is where we take molar concentration times our volume of our solution. And this is very commonly used as well. So typically in chemistry, we are dealing with aqueous solutions. And so we will use this mole formula quite a bit. Here is a typical stoichiometry problem that I will just give you an overview or a review of how to solve. You now have the tools and the knowledge in order to solve this question, but we'll run through the initial steps together. So it says 10 mils of 0.25 molar strontium hydroxide and 25 mils of 0.15 molar iron 3 nitrate are reacted together. Calculate the mass of precipitate that is formed. So the first thing you're going to have to do is come up with your balanced equation, and I'm going to let you do that. So balanced chemical reaction or equation, however you want to say it. Number two, and determine your precipitate in number one as well. Get the solubility chart out and figure it out. Number two, you're going to notice that we have info about both of our reactants. So we're going to have to calculate the moles available of each reactant. And then we're going to have to do a third step where we're going to have to check for your limiting reactant. Once you know your limiting reactant, you're going to figure out the moles or calculate a mole ratio between your limiting reactant and the precipitate. And then lastly, you're going to calculate the mass of the precipitate that you should be obtaining if you carried out this reaction on its own. I will tell you the answer for this question. And that is a mass of 0.18 grams. Okay, good luck solving that.